All right, so continuing our discussion of analyzing of graphs from the first part of these videos, the first step is to first factor. If we were to factor this, we get 3x squared over the difference of squares, which is x plus 3, times x minus 3. Once it's in factored form, it's easy to spot what the y-intercept is going to be. The y-intercept, you simply set x equal to 0. If x is 0 here, you have a 0 on top. On bottom, we'll have 3 times negative 3, which is a negative 9. So we'll have a y-intercept at 0, 0, since 0 over negative 9 is in fact 0. In step 2, we find the x-intercepts. To find the x-intercepts, we set y equal to 0. So we set this whole thing equal to 0, and we solve this for x. Well, recall, in order for a fraction to be equal to 0, all you need to know is that the numerator is 0. So we're going to set just the numerator equal to 0. And you can see if you divide by 3, you have x squared is 0. So clearly x is 0, which again means the origin is the x-intercept. Well, we kind of already knew that since it was also the y-intercept, since they share the same point. Step 3, in step 3, we were asked to find any vertical asymptotes. In order to find vertical asymptotes, you always want to reduce this factored form as far as possible. It's already fully reduced. There is nothing I can cancel, both top and bottom, since there's no factors that are similar. Since it's already in factored form, we state what is the domain. In the domain, x can clearly not be 3 or negative 3, since it makes the denominator 0. When you have exclusions from your domain, that tells me there will be vertical asymptotes at those locations. Those vertical asymptotes will be located at x equals negative 3 and at x equals 3. So let's graph what we have so far. So far, I have a x and a y-intercept at 0, and I have vertical asymptotes at negative 3 and 3. The next thing we're going to do is we're going to now find any other asymptotes. Is there a horizontal or possibly an oblique? In order to determine that, we look at the degree of the numerator and the denominator. You'll see that the degree of the numerator is equal to the degree of the denominator. Since they are equal, that means I will have a horizontal asymptote and it will be located at y equals whatever the division of the coefficients are in front of those squared terms. So in this case, 3 divided by 1, which is 3. So on my graph, I'll have a horizontal asymptote located at y equals 3. So this is what I have for my graph so far. Now we have to find some more points. So in step 5, this is where we're going to divide the x-axis into intervals. We're going to test this interval here, this interval inside here, and this interval over here, and divide this up and find what is the graph doing in between each of those critical areas. The critical areas would be the asymptotes and the x-intercepts. So over here on the side, I'll divide my x-axis up into intervals. We're going to use my vertical asymptotes as a couple key areas. Also, we're going to use x-intercepts. So we're going to use 0 also as one of my critical points. So we're going to test 1, 2, 3, 4 different areas to find out if it's above or below the x-axis. So let's first test on the left-hand side. Let's test the point negative 4. If I test the point negative 4 over here, we're going to find that y equals, so plug this in up here, negative 4 squared is going to be 16. 3 times 16, I'm going to need a calculator here. So I'll do this all at one time. So we have 3 times negative 4 squared divided by, in the denominator, we've got negative 4 squared minus 9. That all comes out to be 6.8 on my graph, which is definitely positive. So positive 6.8. So this means it is above the x-axis. So on my graph, I'm going to graph a point at negative 4, positive 6.8. And since it's in between these two asymptotes, it's going to be a C. And it's going to hug both of those asymptotes, and it will be above the x-axis everywhere in that quadrant. And obviously, if it never crosses this purple horizontal asymptote, it will never dip below the x-axis. Now let's test a point in between negative 3 to 0. So let's test negative 1. So if I put in a negative 1 for x, I can use the same entry that I had before. I'll just change these to negative 1 and positive 1. And I get negative 0.375. Negative 0.375, which is below the x-axis. So let me plot that point. At negative 1, negative 0.375 is right here. And everywhere in this interval, everywhere between negative 3 to 0 will be below the x-axis. So that means it's going to be coming down and it's going to follow that asymptote. But on this side, I don't know if it's going to go up or if it's going to go down. My assumption is it will go down, otherwise it's going to cross through that horizontal asymptote. Again, that is allowed. It's allowed to cross through at the middle, just not towards the ends. But I have a feeling it's going to come back down. So let's see. Let's test another point in between 0 to 3. So let's test positive 1. So if x is 1, y is... let's put this back in my calculator since I've been using that. So let's test a positive 1. And that gives me, again, a negative 0.375. So I get the same value, which means everywhere in this interval it will be below the x-axis. So at 1, we have a negative 0.375, which means it will also be below the x-axis. So I was right. Now on the other side, we have to test a number on this side of the vertical asymptote to see if my C is happening up here or down here. Generally, things like to be symmetric, so I feel like it's probably going to be up here. You'll start to notice some of those tips as you move through some of the examples in your homework. So let's test one more point. How about we test the number 4? Let's test the number 4. So if I go back to my calculator and I type in the number 4, I get positive 6.8, which is above the x-axis. So when I plot that point at 4, 6.8, it's going to be an exact replication of everything on the left-hand side. So this has y-axis symmetry, which means it's an even function. So we're going to do one more graph of x squared minus 4 over x. So in this one, the first thing we're going to do is we're going to find both the y-intercept and the x-intercept. So let's start there. Okay, so first let's find the y and the x-intercepts. So to find the y-intercept, first thing we need to do is factor. So let's factor this numerator. This is the sum of the difference of two squares. And you'll see nothing reduces. So my y-intercept is located whenever x is 0. Well, when x is 0, we have a problem here. Because when x is 0, I get an undefined function. So there actually is no y-intercepts. And you'll see when we move on to vertical asymptotes, there's actually going to be a vertical asymptote located there, which means there can't be a y-intercept. So you'll see why in just a moment. For step 2, let's find the x-intercepts. To find the x-intercepts, we set y equal to 0. So we set this whole thing equal to 0. Again, when we have a fraction equals to 0 and we're asked to solve, we don't care about denominator, we just set the numerator equal to 0. So let's slide the 4 over to the other side. So x can be either positive 2 or negative 2. So I have two x-intercepts. So on my graph here, I'm going to have two x-intercepts at negative 2 and positive 2. In the third step, we're going to find any vertical asymptotes. In order to find vertical asymptotes, it's best to look at the domain first. The domain, I have an exclusion. X, the denominator, can never be 0. That's because there is a vertical asymptote located there. So I have a vertical asymptote located at x equals 0. So this is my vertical asymptote. To find the horizontal or oblique asymptotes, I compare the powers, the degrees, of the numerator and the denominator. The numerator degree is 2, the denominator degree is 1. So the numerator degree is bigger than the denominator degree by 1 unit, which means I have an oblique asymptote. In order to find out where that oblique asymptote is located, we divide. So I'm going to use this space over here to do my division. So let's go ahead and do my division. So I'm going to divide the denominator, which is x, into the numerator, which is x squared minus 4. And again, sometimes it's nice to put placeholders in there because there is a single x inside. It just happens to be a coefficient of 0. So when I do my division, I decide what number times x will bring me to x squared. Clearly, I need an x. So x times x is x squared. I do my subtraction, and I find those are gone. And then you bring down the 0x minus 4. What times x will bring me to 0x? Well, clearly, 0. 0 times 0x is 0x. And then I don't care about the remainder. As long as I have my oblique asymptote in y equals mx plus b form, I don't really care about what the remainder is. It's not necessary. So the oblique asymptote is going to be located at y equals mx plus b, which is x plus 0. So the y-intercept will be at 0, and the slope is at 1. So when I graph this on my graph, my oblique asymptote will be located here. So I have a y-intercept of 0 and a slope of 1. So that's up 1 over 1, up 1 over 1, up 1 over 1. So there's my oblique asymptote. My graph will never cross through an oblique asymptote or a vertical asymptote, ever. The last step is to just find a couple more points if necessary to see whether it's above or below the x-axis in between these critical points. So I'm going to draw the x-axis right here. And I have critical points at the zeros of negative 2 and 2. And also at 0 because that's where my vertical asymptote is located. And then I'm going to test all 4 of these intervals just like I did with the previous 3 examples. So let's test these 3 intervals. First, let's test the point x equals negative 3. So if I test x equals negative 3 in this original equation up here, if I put in negative 3, I have 9 minus 4, which is 5, over negative 3. So you have a negative answer, which means your graph will be below the x-axis. So on my graph, anything to the left of negative 2 will be below the x-axis, which makes sense because it's going to approach this asymptote. Now what happens in between negative 2 and 0? So let's test negative 1. When I plug in a negative 1 for x, I get 1 minus 4 is negative 3 over negative 1, which is a positive 3, which is above the x-axis. So when x is negative 1, y is 3. So when x is negative 1, y is 3. So it looks like it'll be above the x-axis and it'll get closer to the vertical asymptote. You could probably already determine what's going to happen on this side, but let's finish by testing a couple more points. So let's test 1. If I plug in 1, I have 1 minus 3, which is negative 3 over 1, which is a negative number. So the graph will be below the x-axis anywhere in this interval. So anywhere between 0 and 2, my answer will be negative or below the x-axis. So my graph is going to get closer to this green vertical asymptote and continue to be negative below the x-axis. Now let's test a point anywhere from 2 on to positive infinity. Let's test the number 3. If I test the number 3, I get a y value of 9 minus 4, which is 5, over 3, which is a positive number. So that means I'll always get a positive y, which is above the x-axis. So any number above the x-axis will get closer to this oblique asymptote. So this is what the graph of that would look like.